pH meter. What is pH? pH specifies the degree of relative acidity or alkalinity of an aqueous solution at a given temperature. pH is derived from the word pondus hydrogeni, which means potential hydrogen or power of hydrogen. pH is represented in the form of an equation as the negative logarithm of the hydrogen ion concentration. It is measured on a scale of 0 to 14. What does the pH value indicate? The pH value of a substance is directly related to the ratio of hydrogen ion and the hydroxyl ion concentrations. It expresses the degree of the activity of an acid or base in terms of hydrogen ion activity. If the H plus concentration is greater than OH minus, the material is acidic, that is, the pH value is less than 7. If the OH minus concentration is greater than H plus, the material is basic with pH value greater than 7. If equal amounts of H plus and OH minus ions are present, the material is neutral with a pH of 7. Acids and bases have free hydrogen and hydroxyl ions respectively. The relationship between hydrogen ions and hydroxyl ions in a given solution is constant for a given set of conditions, and either one can be determined by knowing the other. A change in 1 unit of pH represents a 10-fold change in hydrogen ion concentration. The pH scale of common products is given here. Pure water has a pH of 7, that is neutral pH. Egg, baking soda, hand soap, ammonia solution, bleach, and concentrated solutions of alkalis have alkaline pH, that means pH above 7. Milk, black coffee, tomato juice, apple juice, lemon juice, and gastric acid have acidic pH, that means pH less than 7. All living beings depend on a proper pH level to sustain life, and hence pH measurement becomes an important aspect of our lives. pH meter. A pH meter is an electric device used to measure acidity or alkalinity of a solution. Fundamentally, a pH meter consists of the following: a voltmeter attached to a pH responsive electrode and a reference electrode, and there will be a temperature sensor and sample solution being measured. Different types of pH meters are given in the picture: digital pH meter, waterproof pH meter, manual digital pH meter, portable pH meter, and benchtop pH meter. The pH responsive electrode is usually glass, and the reference electrode is usually a mercury-mercurous chloride, that means calomel electrode, or a silver-silver chloride electrode. When the two electrodes are immersed in a solution, they act as a battery. The glass electrode develops an electric potential that is directly related to the hydrogen ion activity in the solution. The voltmeter measures the potential difference between the glass and reference electrodes. Here you can see the diagrammatic representation of a pH meter. And this is the measuring electrode or glass electrode, and this one is the reference electrode. And here is the temperature sensor. And the reference electrode is filled with potassium chloride, and there is a silver-silver chloride electrode present inside that. Then there is a liquid junction, and the system is filled with sample solution. And for the measuring electrode, there is a pH 7 buffer solution here in the glass membrane. This is a pH sensitive glass membrane, and there is a silver chloride electrode, and both these electrodes are connected to a high impedance voltmeter. In most of the pH meters, the electrodes and the temperature sensor are fabricated with a single body and called as combination electrodes. Here you can see a picture of a typical combination electrode. And here the temperature sensor and electrode is combined together. The overall potential or the voltage is the algebraic sum of the potentials of the measuring electrode, reference electrode, and the liquid junction. The reference electrode provides a stable voltage as it has a fixed concentration of potassium chloride solution, which is neutral solution. On the contrary, the potential of the measuring electrode depends only on the pH of the solution. The potential difference between a glass membrane of measuring electrode and a reference electrode, which is dipped in the sample solution to be tested, is measured. When two electrodes are dipped in the sample solution, ion exchange process occurs where some of the hydrogen ions move towards outer surface of the measuring electrode and replace some of the metal ions. Similarly, some of the metal ions move from the glass electrode into the sample solution. The sensitivity of the reference electrode potential to changes in pH is negligible, or it is unaffected by the changes in pH and hence provides a stable voltage. Here you can see a measurement electrode with a very thin glass bulb chemically doped with lithium ions so as to react with hydrogen ions outside the bulb. There will be voltage production across the glass membrane. Ion exchange process also takes place on the inner surface of the glass electrode from the sample solution. This creates a potential difference between them. The liquid junction potential is usually small and relatively constant, which mainly depends on the concentration of the ions in the sample solution. All three potentials are summed up and measured by a high impedance voltmeter. The output of the impedance voltmeter is voltage readings, and it has to be calibrated to get precise pH measurement. Calibration is done by dipping the measuring electrode into buffer solution of non-pH, which helps in interpreting millivolt reading as pH measurement of the sample solution at the given temperature. Applications of pH measurement. pH measurement is very crucial in agriculture industry for soil evaluation. Major crops require alkaline environment and hence pH measurement becomes necessary. It's also used in food industry, especially for dairy products like cheese, curds, yogurts, etc. It becomes mandatory for chemical and pharmaceutical industries. It becomes a significant factor in the production of detergents. pH level monitoring is essential in water treatment plants and RO water purifiers. Let's discuss the advantages and disadvantages of pH measurement using pH meter. pH measurement using pH meters is inexpensive and robust. Pocket-sized pH meters are user-friendly. Then readings are accurate and precise. Disadvantages of pH measurement are the following. First one is temperature impacts the output reading, and the second one is glass electrodes must be always clean as deposition on the electrodes affects the reading. Thank you for watching this video.